Today we are talking about what is called a slope field. And a slope field is the graph of a derivative, okay? A graph of a differential equation, okay? Now, when you graph y equals 2x plus 3, does your graph go through every single point on the paper? No, it only goes through the points that satisfy it. What makes these different is that you are going to put graph on every single dot that's on this part. And each of these dots represents one unit. Okay? So it says to sketch the slope field for each of the differential equations. We're taking all the stuff we've been working with for the last week and we're graphing it. All right? So let's take the first one. dy dx equals x minus y. What does that mean? That means the slope dy dx at any point is equal to the x-coordinate minus the y-coordinate. So the slope that you're going to draw is equal to the x-coordinate minus the y-coordinate. So let's start at 0, 0. What would x minus y be for that point?
0.
0. What does a slope of 0 look like? Like this, right? Flat line. So at 0, 0, you are going to draw a little piece of graph with a slope of 0. Every point is going to have a line segment at it. And that line segment will be the slope that is calculated from the equation. Okay? Now, once you get one started, ask yourself, is there any other point on here that would have a slope of 0? Because a lot of times you will find patterns. What's another point that would have a slope of 0? 1, 1. So let's go to 1, 1, which is here. Draw a little slope of 0. When you draw these lines, don't make them too short. You've got to be able to see what their slopes are, but don't make them too long. Don't go any farther than halfway to the point on either side of it. Okay? Where else? 2, 2, right there. Doesn't go any higher than that. Does it work in the negatives also? Negative 1, negative 1? Negative 1 minus negative 1? That is 0. So yes, it does work down here. And then negative 2 does work right there. So all of those have the same slope. Okay. Once you find the pattern and you've filled up all of those, move over to another point. Let's move to this point here. What are the coordinates right here? 1, 0. What's the slope supposed to be? The slope is x minus y, so that would be a slope of 1. Okay? So, when you've got a slope other than 0, take the point where you're starting and just count the slope like a rise over run. So if I counted the slope up 1 and over 1, it would go through this point too. Also, correct?
Yes.
So basically, when you draw your little piece of line, have it point towards that point up there. So you would draw a piece of line like so, pointing to that other point that's up 1 and over 1 from the point that you're talking about. Okay? Is there any other point that would have a slope of 1? 2, 1, wouldn't it? 2 minus 1 is 1. So here's 2, 1. So this is going to have a slope of 1. Would the next one up here have a slope of 1? Yes, it would. 3, 2 has a slope of 1. What about down here? 0 minus negative 1. Yes, that's a slope of 1. So this one has a slope of 1, and so does that one. So the diagonals seem to be always having the same slope. That doesn't happen every time. Sometimes a horizontal group will have the same slope, or a vertical group. But this time it happens to be the diagonals. Okay, let's move over one more. Coordinates right here. 2, 0. What's the slope? Right here, I'm going to count up 2 and over 1. So the line I draw from here has to point towards that place right there. So I'm going to eyeball it, make it about like that. Okay? Since diagonals are following the same pattern, this one's going to have a slope of 2 also. However, I don't have 2 points up to point it towards. What's another way I can go? I could go down 2, couldn't I? Down in which direction would I need to go? Left. So make this dot point to there. So sketch it in like that. That's right. Okay? Do the same thing here. This one's supposed to have a slope of 2 at 1, negative 1. up 2 and over 1, so I'm going to point it towards there. And then this one also, up 2 and over 1, point it to there. Yeah, kind of. Now, one more thing I forgot to mention. Do you notice how all of these in the line that have a slope of 1, they all point towards each other? That is an asymptote, and I'll talk more about that, but it's an asymptotic behavior when they all line up like that. It's kind of a boundary line. Okay? Let's look at this right here. What are the coordinates right at this point? 3, 0. So it's got a slope of 3. 1, 2, I can't really do that one. Just go off the page, so I'm just have to guess. So it's steeper than this, so I'll go like that. This one I can do 1, 2, 3, and up 1. So like that. 1, 2, 3, and up 1. Like that. Wrote it myself. There we go. Okay. Yeah, what is its slope going to be for the next two? 4. That was 0, 1, 2, 3. These are going to be 4, so it's just steeper. Now we can just start guessing. 5 is almost going to be straight up and down. Like what? Like Christmas tree. All right. Now, let's go back to the other side of the horizontals. This one on the x-axis. Coordinates? -1, 0. So what's the slope? -1. So -1 goes this way. So I've got to go pointing towards that point. So it's going to go like that. So all of these are going to point this way. This is a graphic representation of a differential equation. We know what the equation looked like. Now we're looking at the graph. And I will talk about how it relates to real graphs in a minute. Okay? So this is -1. What do you think the next diagonal slopes are going to be? These were 0. These were -1. So these will be -2. Okay? So 0, 2. 0 minus 2 is -2. So down 2 and over 1. So I'm pointing towards that point right there. That one right there. That one right there. Just make them about the same. The next 3 here are going to have a slope of -3. 1, 2, 3. I'm going to have to estimate that one. That's -3. The next 2 are -4, so I'm just going to eyeball those, and then -5 going up. Okay. Has anybody seen something like this in the real world?
I think I've seen this before, though.
Yes, weather patterns. If you've ever looked at weather maps, depending on the channel that you watch, the Weather Channel will do this sometime, when they're talking about the flow of the jet stream, they might use these little pieces of graph to show the pattern of the wind. Okay? This is very common to what they use in weather. Huh? If you could graph it, you could make a graphic representation of it. Yes. Okay? So, this, like I said, is a graphic representation of a differential equation, the kind we've been working with the last 4 days. All right? So, all you have to find the slope, put the dots on there, or put the line segments on there. I want to skip number 2. Please, everybody in this class, hear me. Skip this one. Go to number 3. Okay? Because number 3 is actually going to graph something that looks familiar to you. So in this case, dy dx equals the opposite of x divided by y. All right. I'm going to bring in some scratch paper to do some math. Okay? We start at 0, 0. So that would be -0 over 0. What does that equal? I've heard some people say 0. Okay? I've heard some people say undefined. Would anybody believe that it would maybe equal 1? -1? Can you see -1? Okay. What's the rule that makes it equal 0? Whenever there's a 0 on top, supposed to be 0, right? 0 over 5 is 0. 0 over 10 is 0. Okay? But this one, what's the rule that says it should be negative 1? A number over itself is supposed to be negative 1. Okay? Undefined means there is no answer at all. No. I'm going to tell you right now, it's none of these.
Infinity.
Negative 0 over 0 is what we call indeterminate. Okay? N cannot be determined. Okay? It could be 0, it could be 1. It could also be 99. What? 0 over 0 is 99. Yes, it is. 0 over 0 is negative 2 also. Let me show you why. I like doing this with people. What is 16 divided by 2 equal?
That's 8.
That's 8, because the answer times the denominator equals the numerator. Agreed?
Yes.
Look up here. Does 0 times 0 equal 0? Yes. Forget the negative. Does negative 1 times 0 equal 0?
Yes.
Does 99 times 0 equal 0?
Yes. Oh, you're right.
Does anything times 0 equal 0?
Yes.
That's why it's indeterminate. You don't know what it is. It could be anything. Okay? So, indeterminate means it's actually not a no solution, but it's an infinite solution. Okay?
So infinity.
So it's infinity. It's almost infinity. Infinity is not a number. Infinity is the number of solutions that it has. The answer isn't infinity. The number of solutions is infinity. Okay. So since we don't know the slope right there, we draw nothing. Okay? Because there is a bazillion possible answers to this problem, we don't draw anything at 0, 0. We draw nothing. Because it could be anything. So let's move over. This point here is 1, 0. What is negative 1 over 0? Now, according to the rule I just taught you, could it be 0?
Yes.
Does 0 times 0 equal negative 1?
No.
No, can't be 0. Could it be negative 1?
No.
Negative 1 times 0 equal negative 1? No. What could it be? Okay. It actually can be nothing, because there is nothing that multiplies to 0 to give you negative 1. Think about it. Anything times 0 is always 0. So that's why this is no solution. That's what we call undefined. Undefined means there is no answer. How does a undefined, but this is an undefined slope. What does an undefined slope look like? Straight up and down, vertical line. So here, that one is vertical. So if you mathematically get undefined for an answer, the graph looks like this. No slope. What you learned in Algebra 1 is no slope, or undefined slope. Okay? Are there any other points that are going to have this for a slope? What about 2, 0? Yes. This one, and this one, and this one, and this one. See, that's why you knock them all out. Instead of doing every single pair of coordinates on the whole thing, you knock out as many that are alike as possible. Okay? Now let's do the y-axis. Coordinates right here are 0, 1. So negative 0 over 1 is 0, because 0 times 1 is 0. So this is a slope of 0. Horizontal, 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 horizontal. And now it looks like crosshairs on a scope. Those of you who hunt.
Call of Duty Spec Ops.
Oh, yeah, or play Call of Duty. Yeah, hadn't thought about that.
I also play Call of Duty.
Okay, where do you want to go next? 1, 1. Let's go to 1, 1. That's a nice, easy point to do. When you plug in 1, 1 right here, negative 1. So that's a slope going this way, like so. Are there any other points with a slope of negative 1? Negative 1, negative 1. Let's go up here to 2, 2 first. You're right. You're both right. Then negative 1, and negative 2, negative 2. So those are all four the same. Okay? Let's go to the other diagonal and see if they happen to be the same. Let's go down here to this one. 1, negative 1. Positive 1. So it's going to go this way. Slope of 1 is always a 45-degree angle. It's an easy one to eyeball.
Isn't that one negative one?
That is the point 1, -1.
Oh, so it's negative.
So it's negative, -1, or actually 1 over -1 like that. 2 negatives make a positive. Okay? What about 2, -2? Is it going to be the same thing? Yes. So that's the same. And then up here, same thing, same thing.
Oh my gosh, it really does though. You know
Okay.
So it shoots the photon
Now,
bomb.
I'm going to finish quadrant 1 for you, and then I'm going to let you loose to do the rest of this. Okay? So let's move over here. Coordinates right here. What are they? 2, 1. Some of you may need to write this down and may have a trouble doing it in your head. So that would be -2 over 1, which would be -2. So at this point, we're going to go down 2 and write 1 and point it towards there. Now, diagonally, is that going to be the same slope? Let's check and see. What's the coordinates right here? That's 3, 2. That's not going to be the same slope, is it? No, it's -3 over 2. We can go ahead and do it, though. Okay. Now, I'm going to, because these are beautifully spaced, I can go over into the dots on the next graph. So it would be down 3 over 2. So I need to point it to here, like so. Yeah, I know it's a different graph, but that's okay. Okay, what about this one right here? This is 3, 1. So that would be -3. So from here down 3 and over 1. So I need to point it to there. And then this last lone little dot right here, this is 1, 2. So it's going to be -1 over 2. So that means I go down 1 and right 2. It's going to point over there. Okay? Now, I think almost every table in here has at least 3 people. What you can do is divide up the work. One of you take quadrant 2, one of you take quadrant 3, one of you take quadrant 4, do the rest of them, and then share with your group. And go ahead and fill this in. Okay? Then we'll talk about it and see if you see a pattern emerging. We'll just finish number 3.
So, Ms. Bell, how you put numbers into like the parent -x over y, you pass through these points, right?
That's what I'm about to talk about. I'll show you how it all fits together. No, you're not. You're not. You're just the only one saying something about it. I'm about to show you. I'm about to show you. I want to finish the picture first, and then I'm going to show you. This is a graphic representation of all of the general solutions. Remember the general solutions? The plus C. The C is still in there. Okay. So this represents all the shapes that it could be. I'm going to do the math and show you. Yeah, just hang on, I'll show you. Okay, did everybody get something that looks pretty much like that? Okay, what shape do you see? I see circles.
It's what Luke uses to shoot the photon bomb into the hole of the Death Star.
Exactly.
Oh, I have to go watch that part again.
Except he doesn't use it because Obi-Wan tells him not to.
Turn it off. Okay, now, I want to show you what this is for, okay? So I'm going to take this equation And I'm going to do to it what we've been doing for the last 2 days. And that is to separate the variables. Okay? Now, take this equation, separate the variables. What do I do first? You don't have to write this down, just watch. Okay, dx goes there. Then what? Y goes to the other side. How? How do I move it? Multiply, so the y goes there. So now I have y dy equals negative x dx. Agreed? Okay, what do you do now?
Take the antiderivative.
Antiderivative. Integrate both sides. What does this become?
1/2 y squared.
1/2 y squared equals
Negative 1/2 x squared.
plus c. Okay. Now, if I wanted to clean that up, what would be the next step? Multiply both sides by 2. So that would be y squared equals negative x squared plus just a c. Okay. On the homework, I said you could stop right there, but I'm going to take it a step farther. Move the x squared over with the y squared. Look what you get. Positive x squared plus y squared. What equation is that? That's a circle. That's why this is circular.
Only circle.
Okay, now, what this represents, and let me say it to everybody because I said it to a small group of people. This is a graphic representation of all of the general solutions to this equation. Basically, this gives the general shape no matter what C is. Now, if I told you that I wanted to go through the point 1, 1, could you tell me what the equation would be?
Nope.
How would you find C? You would just plug them in, right? So 1 squared plus 1 squared equals C. So C equals 2. So x squared plus y squared equals 2. What's the radius of that circle?
Square root of 2.
Square root of 2. Okay? Which is, the radius would be about 1.4. Now watch this. I need a pencil real quick. Can I borrow your pencil real fast?
Yes.
I want to be able to erase this. If I went to the graph and I put a dot at 1, 1, and then I followed the lines around in the direction they're pointing me, I would graph a circle with a radius of 1.5. Do you see that? That's what this is for. That's what this is for. Okay. Let me give you that too. All right. That's what this is for. Does that make sense? Okay. So whatever point I give you to start at, you put a dot there. Now the dot may not be exactly on one of these, but it kind of says, okay, go that way, and then you follow till you get to the next one, and then it says go this way a little bit, then go this way a little bit, and you work your way around, and it creates a circle. Sibby.
So then the very first one we did, what kind of equations?
This one is something that you've never seen before. What it happens to be is a graph that, this is an asymptote. It comes around like this, and it comes down like this. It's a radi graph with a slanted asymptote. We did those last year. Something like that. Okay? Now, what I would like you to do is begin work on number 2. Okay? This one has a positive x over y. Some of the points are going to have the same little things on them. Some of them will be different. It is going to make another conic section. Start this one out and see if you can figure out what it's going to turn into while I hand out the homework. Okay. Here is the finished product. We're getting close to the end of class. It's supposed to look like this. You're going to have these two diagonals going this way. They are asymptotes. And then you have graph going this way or this way. What conic section looks like that? Hyperbolas do. They're the ones that go like this. Remember these? They go like this, and then top and bottom. That's a hyperbola. If you separated the variables, you will get a hyperbolic equation from that. We are going to finish with slope fields with this new worksheet right here. It asks you to go ahead and create the slope field for this. So I'm going to give you about 3 minutes. This is a very simple one. I would like you to draw the slope field for this based on what I taught you yesterday. So go ahead and do that right now. Okay. All right. Some of you have already caught on that when the differential equation is in a single variable, as opposed, it's either all x's or all y's. Please listen. Please listen. When the differential equation is in one variable, if they're all x's, if this equation is just x's, everything vertical will always be the same slope. If it's only in y's, everything horizontal will always be the same slope. So these have a slope of 0. This column has a slope of what?
2.
Has a slope of 2. So these are all going to be the same slope. These all have a slope of 4, which is almost vertical. What about this column? -2. And the final left-hand column is -4. Am I going to get out a ruler and measure your lines, and will the AP exam do the same thing? No. They're just going to look for the general shape to be correct. They have made people in the past draw these on the AP exam, usually giving you about 10 dots, and that's it. Okay? Just kind of getting the shape. They haven't done it last year or the year before, but 3 years ago they did. So who knows if it'll come back. I mean, and that's an easy way to get 2 points right there, or 1 point. Okay? Now, let's go to the bottom. We're now going to do some analysis. I want to talk for a minute first about this right here. Okay, yesterday I showed you this. I showed you how the differential equation relates back to the graph. And of course now, there it is. Okay, yesterday I recorded it as well. We went through, we separated the variables, we did the math, we came up with this equation here, the general solution. That's what all the lines are. It's the pattern of the general solution. Once you get a specific point, you plug it in, this comes up with the particular solution, but if on the graph, if you put a dot at that point and you just kind of follow the pattern around, it gives you the graph of this particular solution. Okay? So that's how they're related. Now, at the bottom of this page that we're doing today, I have pictures of particular solutions. In other words, they erased the slope field and they filled in the pattern. This is the solution. Okay? So it says to determine which graph shows the solution of the initial value problem without actually doing the math. In other words, don't separate the variables. Just look at it and figure out which one would be right based on this derivative, this differential equation, and that starting point. dy dx equals 1 over 1 plus x squared, y of 0 equals pi over 2. Do all of these graphs go through the point 0, comma pi over 2? Yes, they do. Okay? So, out to the side, I'm going to go ahead and do some math. What I'm going to do is actually find out what the slope should be at that point that's definitely there. So I'm going to write dy dx at the point 0 pi over 2. What should it be? It should be 1 over 1 plus what number? What number am I plugging in for x? 0. Squared. So the slope should be 1. Agreed? Okay. Which of the 3 graphs has a slope of 1 at that indicator point? A, B, or C? B does. B is the correct answer because the slope right there is a positive 1. What is the slope on the first one? Because it asks you to say why the other two don't work. What's the slope right there?
0.
That slope is 0. So underneath it, write m equals 0.
-1.
And this one is negative. It's probably -1. It doesn't really matter what number it is. What matters is the fact that it's negative. And I'm supposed to come out with a positive answer. So, do you understand how we figured out that B is the right answer? Okay. I want you now with your table to do the next one. Okay? Come out to the side, figure out what the slope should be at that critical point right there, that point in question, and then figure out which one is correct. So go ahead and do that right now. What did you get the slope to be?
1.
Positive 1. So which answer is correct?
B.
B is again. This has a slope of 1 because it goes like that. This one has a slope of definitely -1. How do I know? Because it's point -1, 1, and 0, 0.
So
Okay.
it's asking for the slope at that point.
Correct.
Okay, I was looking for
And this one has a negative slope also. Is a negative number. I don't know what, but it's negative. The only one with a positive slope is B. Okay, turn over in the back for me, please. Okay, we are going to do the top together. Actually, I'm going to get another copy of this because it has bled through pretty bad on this one. So, okay. It says use slope analysis to match each of the following differential equations with one of the slope fields A through D in figure 6.1. Do not use your calculator because some calculators actually have slope field capability. So I'm going to do this in red so it doesn't show through so badly. Here's your first differential equation. What I want to do is I want to look at where this differential equation equals 0, because when you look at these pictures, and it gets kind of mind-boggling at times, you can not really tell whether a slope is 1 or maybe 1.5 or 2, but it's pretty obvious where the slope is 0. You agree with me? Flat lines are pretty obvious to tell what they are. So what I want you to do is to take the differential equation and tell me what value of either x or y would cause the derivative, this differential equation, to equal 0. So in this case, when what equals -2? When y equals -2, the slope would be 0. All right. Now, which graphs do you see that have a horizontal, 0 on a horizontal, where you have a bunch of little lines that are a 0 slope? I see A, but I don't see C, A and D. No, I don't see D either. Is it B? Okay, B has one down here. You see that B has one down here. A has one below the x-axis and above the x-axis, doesn't it? Now, do you notice that this one down here is 4 marks down? And this says -2. Don't necessarily assume that every mark is 1 unit. The fact that this one only has 1 line and this one has 2 tells me that A is wrong. Does that make sense? The only place where they should be horizontal is at y equals -2. So that means that B is the correct answer for this one. It's the only one with one horizontal pattern of flat lines.
So how did you get, did you just solve for...
I just figured out what value of y, or what value would cause this dy dx to equal 0. Because when dy dx equals 0, you can obviously see it's flat. Okay? Number 2, what value would cause this to be 0? When what is -2? X. When x is -2, the slope is 0. So it's definitely not B. Which one do you think it might be? I think it's D because it's pretty close. It looks like now that each of these is 0.5 because that other one was 4 marks down and it was really what, -2? So -2 would be 4 marks this way, so that is correct. It happens to be D. X equals -2, remember, is a vertical line. So you used to have a vertical line full of flat little slope ticks. Number 3. Now you may not be able to do this one in your head. Let's do the math. 1 plus cosine of x equals 0. We want it to equal 0. So how do you solve that? Move cosine of x equals -1. Where does cosine equal -1? Think of the unit circle.
Pi.
At pi, over on the left side. So x equals pi, which is about 3.14. Okay. So between A and C, where does it flatten out at x equals 3.14? It is C because it's flattening way over here. So it is C. Why is it C? Because Now, actually, it's not just pi, it's also negative pi. Do you agree with me? Do you notice that it's flattening right here? And it's also flattening way over here on the left? So it's going to be C. Another thing, let me talk about this as well. For those of you who are very visual learners, you understand things more visually. If this is the derivative, what will you definitely see in your original equation? What kind of a function? If part of the derivative is cosine, you're going to see a sign in it, right? And so these are the patterns of the original equation. Which one between these two looks kind of like doing a sine wave thing? Possibly spread out. Do you see that this one's going up and then it's coming back down? Do you see the pattern that way? That one looks sinusoidal. So C is the correct answer. This one does not look like a sine wave at all. A does not. Now, you may think, oh, D does. Well, maybe you hadn't done that one yet. No, D's really not either because it flattens out and then it's going up forever. Do you see that these are just getting steeper and steeper and steeper? It's not flattening out again, so it can't be that one. That's probably an exponential or quadratic. Okay? Now, let's do the math for 4. When what equals what? You tell me. Y equals? Plus or minus 1, M equals 0. So, this one needs 2 flat lines. One at -1, right here. One at +1, right there. So it has to be A. Well, A is the only one left anyway. Now I proved to you why it's A. Do you have any questions? Okay. At the bottom, I would like you with your table to omit 17 and 18, but do the other 4. I'm still going to give you all 6 to choose from. So, of the 6 graphs, I want you to match up 4 of them with these 4 equations right there. I'm going to be walking around to check it. Once I check your 4 and they are correct, then you are free to work on your calculus homework, because this is all we're doing today. I'm recording, I think. I am. E. E. A. F. Is the answer.